Bismillahirrahmanirrahim. Welcome to Pakistan International School Class. This is Professor Fayaz Abanchandu. Now, dear students, grade 12. In grade 12, we started chapter number 13. This is the lecture number 2. And we started S and P block elements. If you open your book, the first chapter, 13th chapter for the second year class, grade 12, S and P block elements. So S and P block elements, period number 3 elements. Period number 3 elements, these are the sodium, magnesium, aluminium, and silicon, phosphorus, sulfur, chlorine, argon. So we are talking about these. If you remember the previous lecture, we started these. So we are now going to study, we are going to discuss period number 3 elements. And before this lecture number 1, I told you about the atomic radius. Now we discuss the electronegativity and other topics also. You done in the grade 9 in the lower classes. Electronegativity. The ability of an atom, the power of an atom to attract the shared electron pairs itself is called electronegativity. You done in the grade 9. Electronegativity. So, dear students, as you are going to number of periods from left to right in the periodic table, from sodium to argon, atomic number by 1 is going to be increased. Sodium is 11 and argon is 18 by 1, 12, 13, 14, 15, 16, 17 and 18. And in the previous lecture I told you, when we done the atomic size and atomic radius, it was totally depend upon the shielding effect. Number of shells. In period, if you go from left to right, number of shells will be same. There will be no increasing of number of shell. Means in the third shell, in shell number 3, KLM shell, so from sodium to argon, 1 electron is going to be increased. Number of electron in the same shell is going to be increased. Sodium is present in group number 1, 1 electron, 2 electron, 3, 4, 5, 6, 7 and 8 electron present in the valence shell. Third shell. So gradually, slowly and gradually, number of electrons are going to be increased the same shell. And nuclear charge, number of protons in the nucleus, nuclear charge we called. So nuclear charge also going to be increased because sodium atomic number is 11, so proton should be 11, electron should be 11. So slowly and gradually, number of protons are going to be increased. Nuclear charge is going to be increased 11, 12, 13, 14, so on and so forth. Slowly gradually increasing. So these two things. Number 1, I told you, periodically, slowly and gradually, number of electrons in the same shell are going to be increased. And second thing, nuclear charge is going to be increased. So dear students, it means that the size of shell is going to be compact, so whole size atom decreases, and the ability of atom to lose electron also going to be decreased. It means that slowly and gradually the atoms can attract electrons towards themselves, not donate. So that is why electronegativity increases. right in periods, especially in period number 3 from sodium to chlorine, the electronegativity is going to be increased. So in this period, sodium is the least electronegative and chlorine is the most electronegative. I'm not talking about the argon because its octet is going to be complete. It has a stable electronic configuration. So chlorine is the most electronegative in this period and sodium is the least electronegative in this period. According to students, according to Pauling scale, in the whole periodic table, fluorine, period number 2, second last element, has a highest electronegativity, that is a 4. In the whole periodic table, according to Pauling scale, the value of electronegativity is 4. Highest. It means that fluorine is the highest electronegative, means it has a more power, highest power to attract the electron toward itself. The reason is the smallest size. Only 9 atomic number, only 2 shells, and number of protons present 9. And the least is cesium or calcium, only 0.7. 0.7. It is present in the group number 1, sodium, potassium, last one, cesium. From cesium is radioactive, I am not talking about radioactive. So cesium, the 0.7. So this has the least electronegative, most electropositive element. And this is the most electronegative, least electropositive element. So that's why a very strong bond is formed between calcium or cesium with fluorine. Very strong bond, ionic bond is formed between these two elements. Because the greatest electronegativity difference between these two elements. More the difference of electronegativity, more ionic nature. So more ionic nature is there. So I'm not talking about this one. So sodium is 0.9. If you see the electronegative value of sodium, it's the 0.9 according to Pauling scale, and chlorine is a 3. So as you move from left to right in the periodic table in the periods for period number 3, so the value of electronegativity is going to be increased. For the sodium 0.9 and for the chlorine this is a 3. So this is the trends in the periodic table. So on, yes, this is same in your book also. Now there is another one. We have explained the physical properties. Physical properties for these same elements. Physical properties of these period number 3 elements. So in the physical properties number 1, structure of elements. So number 1 thing we have to discuss about the structure of the elements. Now if we are going to categorize these elements, dear students, sodium is a pure metal. Magnesium is also metal. All these properties are interlinked. I told you last lecture that periodic table is a mirror of the chemistry. Means physical properties, chemical properties, other you can find from this one. So every point is linked with each other. I told you electronegativity increase from left to right. It means that non-metallic character of the elements increase from left to right in the periodic table. Non-metallic character. It means that sodium is the most means positive or most metallic character, and argon, chlorine are the least electropositive, most electronegative, or most non-metallic character. So sodium is a metal, magnesium is metal, aluminum is metal, but this metallic character decreases from sodium to chlorine. So when we are going to categorize these three elements, sodium, magnesium and aluminum, these are the metals. Silicon, this is now a modern computer period. This is computer technology. So you heard about the chips, silicon chips. Silicon is a semiconductor. Silicon atomic number is 14. This is the 14 atomic number after aluminum. Silicon is a semiconductor. So dear students, it is semi-metal. Means it has somehow metallic properties and non-ferrous metallite. But in normal cases we can say it's non-metal, but some books they say this is not. Both characteristics are present in this one. So silicon is a non-metallic and also metallic properties. Phosphorus, sulfur, chlorine, argon, these are the totally non-metal. They have a totally non-metallic character. So now when you are going to see their physical properties, structure of element, sodium and magnesium, aluminum, they have the ionic, they have metallic nature. And you know the metallic bond is present. If you revisit grade 11, the types of bonding, there is the one special kind of bond which is called metallic bond. Electron C, electron gas. I'm not going to discuss this here. So electron C, electron gas are metallic bond. A special kind of bond is present in metals. So due to the special kind of bond, metallic bond, so they have the three-dimensional giant structure. Three-dimensional giant structure of metals. So due to this giant structure, metals are hard and heavy. If you see the melting point, boiling point, we will discuss this. So metals, they have a special kind of structure. Silicon. Silicon also, dear students, have the very complicated and special kind of structure. Also, it forms a giant covalent bond. One silicon is going to be like this one. Giant structure like this. So it also gives a three-dimensional structure for the silicon, especially in the silicate. The silicon also has a very high melting point, boiling point to form a giant covalent bond. And other, after phosphorus, sulfur, chlorine, they have a weak force of attraction, molecular forces. They have, these are called molecular. They are in the molecule. So if I see phosphorus, so P4. If you see sulfur, S8. If you chlorine, Cl2. Argon is a monoatomic molecule. So they are in the molecular form and they are in the phosphorus and sulfur, they are in solid, low melting point, boiling point. Chlorine is a gas and argon is also gas. So they are the simple molecules, molecular form structure, molecular structure they have. Simple molecular structure. So students, sodium, magnesium, aluminum, they have a giant ionic structure, metallic structure, metallic bond is there. Silicon has giant covalent bond, very strong bond again, very high melting point, boiling point. And for the phosphorus and sulfur, chlorine, argon, these are the simple in the molecular form, and argon is called a monoatomic molecule. This is the structure. Now here, again in explanation is given here, the three metallic structures. Again this topic same is given here. in the metallic structure, again I told you, sodium, magnesium, aluminum, they have the sodium atomic number is 11. And if you want to calculate its electronic configuration, 3s1. In the last 3 is for the period number S block and then 1 electron. So this is group number 1, 3s1. And magnesium is a 3s2. Aluminium, there is a little difference, 3s2 and 3p1. Yes, these are the last shell electronic configuration, valence shell electronic configuration for the metal, sodium, magnesium and aluminum. You see aluminum behavior is a little bit different. There is one more electron present in the P. So that's why the students see this one. The 3s electron present in the sodium and also 3 electron present 2 are in the magnesium in the outermost shell. So they are going to be a metallic nature and very strong metallic bond is there. And in the aluminum, they are a little bit different here. 2 electrons present in S and 1 electron present in the P. Also it has a metallic nature and special arrangement for this one. So if you study the structure of sodium, there is one thing very important we will discuss in the next chapter in very detail, coordination number. Also in first year grade 11 you done in the bonding chapter. Coordination number. The number of electrons are surrounding towards the center. How many number of electrons are surrounding? So, coordination number of sodium is 8. Sodium has 8 coordination number. Each sodium atom is touched with the 8 more electrons. Magnesium, aluminum, that is a 12 coordination number due to difference of electronic configuration, atomic number. So sodium has 8 coordination number and aluminum and magnesium they have the 12 coordinations number in this one. And also in the silicon I told you joint covalent bond is there and its structure is about tetrahedral type and all silicon atoms are joined with a very strong with the center one. So that's why it has also very high melting point and boiling point silicon. For the other elements, there are silicon, apart from silicon, phosphorus, sulfur, they are simple molecular form. There the simple covalent bond is formed, molecular structure. So P4S8Cl2N argon is given here. So their melting point, boiling point is very low because of very good weak forces are there, and you know these forces are called van der Waals forces. So van der Waals forces are very weak in the phosphorus, sulfur, chlorine and argon. That's why they have a very low melting point and boiling point. So these are the points which we discuss here about the structure. The structure of these elements, period number 3 elements, structure I told you. In the physical properties. There is one thing more. Number 2. Electrical conductivity. Electrical conductivity, now you have observation in your daily life that some substances are good conductor of electricity and some are partially and some are non-conductors. Just like Iron is a good conductor. Copper is a very good conductor of electricity. Silicon is semiconductor, half conductor we call it. Plastic, carbon, not graphite only. I say that it is carbon, diamond. These are the non-conductors. They do not conduct electric current. Now the question is that why some substances are good conductor and some are not. So this is due to the free moving electrons. If the free moving electrons are present in the substance, so it can conduct electric current. If there is an absence, if the electrons are, free moving electrons are not present, then this is called insulator or non-conductor. So, this is the period, number 3 element, sodium, magnesium, aluminum. Sodium is metal. So it has a one electron present in outermost shells. So which is a free move to move. So it can conduct electric current. Magnesium, aluminum, sodium, magnesium, aluminum, they are metal, they have metallic cluster, they have metallic character, they have metallic bond. All these elements, they have a free moving electrons. So these are the good conductor of electricity, either in the solid form or in the molten form. Silicon, I told you, which is a semiconductor, half conductor. Phosphorus, sulfur, chlorine, argon, these are the non-conductors. They are not going to conduct electricity because they have non-availability of the free moving electrons. So this is about conductivity. Now, students, there is another thing. Melting point and boiling point. Melting and boiling point. Now, if you see these elements from sodium to argon, the melting point, boiling point, sodium very low melting point. If you are going to compare sodium, magnesium, aluminum, these metals, sodium has the least melting point as compared magnesium and aluminum. So from sodium to aluminum, the melting point and boiling point of these are going to be increases due to the number of electrons in the metallic structure in the valence shell is going to be increased. Silicon is a metallite, somehow non-metallic nature. So it is a very high melting point, boiling point. It's non-metallic nature mostly. So it is very high. The reason is a giant covalent structure. Due to the giant covalent structure of the silicon, all the silicon atoms are surrounded by the center silicon. So it has a proper joint structure. So that is why it has a high melting point and boiling point. So silicon has a very high. So when you going to cross the silicon, so tremendously phosphorus, sulfur, chlorine, argon, phosphorus, sulfur, chlorine, argon, phosphorus, sulfur, chlorine, argon. Now students, already I mentioned that here phosphorus consists of 4 atoms. You know red phosphorus and white phosphorus. I'm not going to explain the allotropic forms. 4. Sulfur 8. There are many also electrons. Rhombic sulfur, mononucleic sulfur, many. So chlorine 2. Argon mono. Tetraatomic molecule. Octa. There are 8 atoms. Diatom, monoatom. So if you see the graph from silicon, very high melting point, boiling point, graph is very high. Tremendously, after crossing silicon, phosphorus is going to be decreased. No matter. Molecular structure, van der Waals forces are there. It's going to be decreased. But when it crosses phosphorus sulfur, little bit increases. The melting point and boiling point of the sulfur are greater than that of phosphorus, because of you are seeing in the structure there are 8 atoms. 8 atoms of sulfur, yellow color, insoluble in water, combustible for both phosphorus also. Sulfur consists of 8 atoms in the structure. 8 atoms are joined with each other, and here are 4 atoms are joined. So due to this reason, more number of atoms in the structure, so a little bit high melting point, boiling point. So now from sodium to aluminium, the boiling point, melting point is going to be increased tremendously, and when we reach silicon, also very very high. Near about similar to aluminium, its melting point, boiling point very high. So, but when you cross the silicon, decreases very tremendously decreasing, because molecular, they are molecular in nature. Van der Waals forces, weak forces are there, so it is going to decrease. But when you increase, reach of sulfur, little bit increasing. Already I told you, because 8 atoms are there. And chlorine is a diatomic molecule, so it's very low. And argon is a monoatomic molecule. This is the least or bottom line. It's at the bottom line, very low. So this is, students, a melting point and boiling point. Melting means when you heat a solid, just convert into a liquid state. Boiling means when you heat a solid, when it's going to become boil at the temperature, this is the boiling point. So these are the very important questions will be asked here. And there is a one quick quiz. If you open your book, there is a quick quiz. The very simple question is that write down the symbols of period 3 elements are already written here. Very simple question. Which of the above elements are S block elements? S block element is only 2. These are the S block elements. Sodium and magnesium are the S block elements. From aluminium to argon, these are the called P block elements. But in the question, here, which are the S block elements and which are D block elements? There is no D block here. None of the elements they are present in D block, transition metals. There is no transition metal here. So these are the P block elements. So first two elements S block elements, and rest of aluminium to argon, these are the P block elements. This is the question number 2. Number C, write the empirical formula of the chloride form of the element with the atomic number 13. Atomic number 13 is for the aluminium. So students, generally we write aluminum chloride in this form. This is the molecular form of aluminum chloride. Molecular. If you study more, you will find the molecular formula of aluminum chloride. So its empirical formula, simplest formula is AlCl3. Ratio, simplest ratio divided by 2. Empirical formula is simplest ratio of the atoms present in a molecule. So this is the simplest ratio. So this is the empirical formula for this. This is the molecular formula for this. And the last question is, describe briefly how can you prepare the sample of this. So just by a combination of aluminum and chlorine, so you will get the aluminum chloride. So this is the preparation of aluminum chloride. Aluminum and chlorine to give aluminum chloride. So these are the physical properties of the elements. So dear students, in the next we will study the chemical behavior, chemical properties. Now, chemical properties. Chemical reactions. Chemical reactions of period 3 elements. All sodium to argon. So, first one is reaction with water. How these elements react with water? Number one is sodium. Now, dear students, if you explain the reactivity of the elements, the reactivity of elements in the period from sodium to argon decreases with water. Their reactivity decreases from left to right in the periodic table. It means that sodium is the most reactive metal in this period. And mind it, this reactivity increases as we go down the group from top to bottom. From top to bottom, this reactivity is going to be increased. So, dear students, if you are putting sodium metal in water, sodium has a less density than water. Less dense. If you drop it, vigorous chemical reaction, fast chemical reaction, flows. This is called a hissing sound. It produces hissing sound, floats on water and react with water to form a sodium hydroxide and hydrogen gas catches fire. So this chemical reaction is highly exothermic. Exothermic reactions. If you put a big piece, this is dangerous. Explosion. So very fast chemical reaction with sodium with normal water, no condition, just drop in the cold water. So chemical reaction is very fast. But if you see in the magnesium, you will find in your book two chemical reactions are given. With magnesium, there are two chemical reactions. So dear students, if you are going to put a very fine magnesium, you have to clean it. There should be no magnesium oxide layer on the magnesium metal. You have to clean with a sandpaper. After cleaning, very small pieces of magnesium, if you drop in the water, the chemical reaction will be slower as compared to sodium. Slow chemical reaction. Already I told you the reaction is going to be decreased as we go from left to right. Slow. So, slow chemical reaction, but you will find magnesium hydroxide and hydrogen gas. Magnesium hydroxide and hydrogen gas is going to be formed with the finally divided magnesium drops in the water liquid, the chemical reaction is slow as compared to the previous one, and you will get magnesium hydroxide and hydrogen gas. But dear students, if you are going to react this magnesium solid with steam, condition change. Steam is passed. So when you pass steam over the magnesium, so you will find magnesium oxide and hydrogen gas. You will find magnesium oxide and hydrogen gas. So two different reactions, different conditions. So you have when you write the chemical reaction, it is very important for the students to write down their proper conditions. What conditions are? Here I told you, finally divided, magnesium drop in a water, this reaction. And here, when the steam is passed over magnesium, you will get magnesium oxide and the hydrogen gas. Now aluminum. Again I am telling you the chemical reactivity decreases as you go from left to right in the periodic table. So here aluminum powder. You learn in grade 12 in the chemical kinetics surface area. So when you make a powder, aluminum surface area is going to be increasing. So aluminum powder is heated with steam, gas, heat, steam. Here also heat, make a steam. So for the time being you will get aluminum oxide with hydrogen gas. Aluminum oxide is going to form with the hydrogen gas. So 2, 3 and 3, yes. And after reacting, after some time the chemical reaction is stopped. Also maybe here the chemical reaction will be stopped because the protective layer of aluminum oxide is going to be formed on the metal. This property is called, dear students, passivity. These elements are passive. Aluminum does not corrode. Aluminum metal does not corrode. So it does not rust because of naturally, if I put in the room temperature, it somehow slowly and gradually react with the atmospheric oxygen and to form aluminum oxide. This aluminum oxide, very thin protective layer is going to be formed on the aluminum metal which protect further from corrosion. That's why very stable. So here the chemical reaction may stop. If you see the chemical reaction of chlorine with water, so you will get hydrochloric acid and hypochlorous acid, which we call chlorine water. Chlorine, and this chemical reaction is reversible. Hydrochloric acid and hypochlorous acid. Hydrochloric acid and hypochloric acid, and even this is somehow in dark, but if you are going to react in the sunlight, so you will get more hydrochloric acid with oxygen gas. Like this. This is sunlight. So this is a reversible chemical reaction. This is sunlight. If you give, so you will get more hydrochloric acid and oxygen gas. So chlorine dissolved in water. I told you to form a chlorine water. Chlorine water is going to be formed and this chemical reaction is a reversible chemical reaction. You will get mixture of hydrochloric acid and hypochloric acid, but in the presence of sunlight, so the chemical reaction is going to form the hydrochloric acid and oxygen gas. Students, argon, because it is inert and does not react with water. So dear students, today in the lecture number 2, we discuss about the physical and chemical properties, and especially chemical properties of the period 3 elements reaction with water, melting point and also boiling point. So this is the inorganic chemistry already I told you, and you have to go through this very big chapter, and not very difficult because you done in the grade 9 also some topics, and also bonding, electronegativity, other things. So we repeat this. So this now we finish this lecture. Thank you very much, and you have to prepare yourself from this book. Thank you.